Hi Uli, nice to see you.
You're very welcome, as usual, you're very welcome.
The research here at the Institute, right? What is it focusing on? Or what are you actually researching on here at the Technical University of Darmstadt?
That's, say, quite a broad range. Obviously, a civil engineering faculty, we have to deal with fundamental research. So we do a lot in mechanics of glass, how glass behaves, how it breaks, how you eliminate it, how you pre-stress it, what the consequences of this, how it breaks, the brittleness of glass. That's something which we are pretty much interested in. So there's a broad range which we later going to see also in the Glass Competence Center as, say, research. Energy is obviously an aspect. Recycling sustainability is obviously an aspect. Circularity is an aspect.
Let's have a look.
Let's have a look. Hang on. The 3D printing. That's something which interests me a lot. This is, say, a new technology, and there's rarely someone who's really able to do 3D printing, 2-3 units in the world, and we are one of them. Let's go.
Oh, let's see. Uli, so you are the expert with 3D printing. And what do we have here?
One field we are active in is bricks printing or clay printing. So we normally extrude, which is a certain technology, create this, but it's, say, defined by shape. And if you want to have different types of shape, you may print these. This is a printed brick, a typical German brick size, which we can use. And where do we get this special? If you're able to get additional functionality integrated. So if we, for example, take this one, which would be a normal extruded brick versus something like this, and you directly see it has an entire different geometry. The surface is different, which is appearance, but it also has some, say, building physical potentials. But you're not interested in brick. You're from the glass field. So when we normally build facades like this facade, it's a stick system. So we have posts and rails which create this typical stick system, which has a rectangular connection. If you want that somehow freeform, the question is, how do you make this? And this is super interesting. I like it a lot. This is a solution for getting this not rectangular stick system connected. So you can imagine a stick system being extended here, and then the glass is placed on top of it, and then there comes the cover cap, and then this is a, say, freeform facade.
So you really can build a facade as an architect in a very special shape then, right? So you're free to install a facade of ever shape, right?
As a scientist, I have to say, in whatever kind of shape you want. As an architect, I have to say, well, there's some boundaries, technical issues, but that's, say, research. That's why we do research.
But it's 3D printed,
this is
right?
This is 3D printed. This is aluminium 3D printed. Yeah, I'm really proud. This is a good product. And we see other things. Actually, we're going to see on the glasstec, we're going to see in a 3D printed stainless steel version. It's going to be a super large device. That's really going to be interesting.
But I know you also print glass.
Exactly.
Right?
You're the glass interested one. So this is one of the very first pieces 3D printed glass. It's actually from Lisa Ramig.
Nice.
She's defended her PhD. So that's the very, and you see, it's not that perfect. This is an 10-year-old sample, so that's when this idea started. And then, as with research always, it takes time and takes time and it takes time. And then you do the next one, gets a bit better, and you do the next one, which gets even better.
More precise, right? Yeah.
And then, interesting-wise, at glasstec 2018, I met QSIL. They had this small stand, and they were actually showing their technology of printing glass, and they didn't know what to do with it. And we got in contact and started investigating and developing the next opportunities. And this is where we are now. We actually did build a glass printer. And on glasstec, you're going to see samples of our printer. The interesting thing is this is a loose part printed. But what we really need for our environment, for our construction, we need prints on the surface. And that's what this glass printer, which we built in Darmstadt, is able to do. So we're going to see results of that printing process here developed in Darmstadt on the glasstec.
But now you had 4 years, right? So I think we probably made a huge step in that. But
it's science. It's small components. You have to investigate how to make it, and then you have to find the industry to really increase it. So the real increasing steps, that's something where we need industry.
But this is where glasstec comes into play, right? To bring the connection between science and...
This is a super sample. I saw the company there. They were having this device. It really feels like, yes, this is a good solution.
All right, so this is something very special, right? 3D printing.
Yeah.
But where is the normal glass heading, or the insulating glass?
Normal insulated glass. So we see, say, this is section normal insulated glass. Forget this brick, that's something different.
But I love it, right? It's beautiful.
Oh, come on, this is huge. We're aware of this nice projects done by our colleague Rob Neisse and the company ABT, which did this how's it called, Crystal House in Amsterdam. Wow,
love to see that in more buildings.
Different story. And then this is a solid one. Then if we go on, we see this is laminated glass. So yes, lamination technology and the performance of that is something interesting. Our institute's current belief is the, say, improvement and broadening in the market of vacuum insulated glazing. This is something we really believe. This is a typical insulated glass unit. 2 layers of glass, the cavity serves a certain U value is 9. But when we go for insulated, vacuum insulated glass, which means
for you?
No, I keep it. I need to show. This is a vacuum panel, and you see the size with a kind of similar U value, and that's really a game changer. This is something which you can imagine really being pushed intensively to the market. And if you want to even improve that one, you may come to this solution, which is a hybrid. So it's an insulated glass unit plus a vacuum glazing. But you know what? We should ask Jens about this, because he did already build this.
All right. Vacuum insulating glass. What is so special about it? What makes the big difference to normal insulating glass?
Yeah, maybe I can explain here in this little small sample. This is a lab sample. This is also why it doesn't look so nice here at the edge. But it is that you really have a vacuum between the 2 panes, which means you have here in exhaust position where you can really suck out the air.
All right.
And then, because the 2 panes would like to go together, because you have a 100 kilopascal of atmospheric pressure, you need little pillars. You maybe see those here.
To keep the distance between the 2 panes. All right.
They are only 200 micrometer to keep the distance very, very small. But this distance is enough to have a full insulating effect, which results in a U value of about 1.1 only with this very small, thin setup, which is interesting. But of course, you have to solder it at the edge because it has to be hermetically sealed, and polymeric sealants cannot stand this. They would leak. And here you have a real hermetic sealant with a solder glass.
And why is it, if it's so effective, right, and small and very nice, I think, in terms of architectural appearance as well, why is it limited or not yet in the market as it could be?
I think it's just because the production of this insulating glass is, of course, is a high-tech thing.
All right.
So what you need, of course, is to have the right machinery, and the distance is 0.2 millimeter, which is very, very small. So it also has to be very flat, and you have to place these pillars. You have to suck out, you have to do the soldering. So the technology is one issue. The other one is, which I don't quite understand, because maybe you see this is also here, vacuum insulating glass, a hybrid one, I will explain in this sample later. But architects sometimes complain that, maybe you can see it here, that the pillars disturb the appearance. But this is only when you go very closely. I mean, now distance is maybe half a meter, but as soon you have to know it. And
you cannot see it in here, right? No.
Yeah. So this is another reason. And then, of course, it's a question of, I always call this in the building environment, the innovation awareness is not well enough, because the building industry is extremely conservative. Right. So never change is very often the issue. And as soon as you bring new products to the market, also the competitors would say, yeah, but this is not good. So there are different issues, but I think there will be a market for it, and there is a market for it, and because it's so lightweight. Yeah. And we have to save material. We now see it. There's a lack of sand, and you need just much less material in comparison to regular insulating.
And I'm sure, right, at glasstec we will see the technology that can actually produce these products, right? So let's work on a better awareness on the functionality of this product. Maybe we need to support the product with the construction industry.
Yeah, that's true. That's true, and that's exactly why, for example, this hybrid one. So this now is a composition of a vacuum insulating glass, and then a spacer, and then a regular float glass on the outside. This is exactly what we put in here.
Alright.
So we do here measurements. We compare the regular IGUs with a vacuum IGU, and this hybrid construction. Because now this has a U value of 0.7 watt per square meter Kelvin, which is like a triple insulating glass.
All right, which is much bigger than normally, right?
It's much, you see, it's much smaller.
Yeah.
And also the dead load is less, and the existing frames and the existing systems that are provided by the system suppliers, they can be used. And this is also a big benefit because it's not so thick and not so heavy. It's more easy to install. So I think there are many opportunities that we can have if there's a real market where also different competitors come with the product to the market, and then it will spread, I'm sure.
We are now standing here at the ETA factory, right? So what is ETA standing for? What kind of research do you do here?
Yeah. So the ETA is the Greek symbol for efficiency, and here we try to use energy the most efficient way that is already been used in a process, here in the machining process.
So it's actually a production facility?
Yes.
All right.
We have real life production facility of machines that do that work with metal pieces that can be grinded, cleaned and polished, and then used in typical machines that are exported worldwide from German engineering, let's say, and also in the car industry, for example. And these metal works, they use machines, and these machines use a lot of energy. And we try now to get the waste heat around the machines, collect it, save it, use it in a different machining process, for example in the cleaning process, or use it for the building, to heat the building in the winter. And also we have the facade equipped so that we can have the waste heat being sent to the outside of the facade and then have a free cooling instead of having cooling machines. Because also these cooling machines use a lot of energy.
They also need energy again.
Yes. So the idea is always to save energy by reusing the thermal energy here within the building, and that is where we can save about 40%.
40% of the energy,
yes,
which is then reused in the system.
Yes, yes.
So this is a big topic as well, right, at glasstec this year, sustainability or the reusage of energy. So this is very, very interesting. But you also have the Glass Competence Center here, right?
Yes, correct. This is just across the street. We can go over there to Matthias and then have a look in the Glass Competence Center.
All right, let's go. So, and what kind of glass processing can you actually do here at the Glass Competence Center?
Here we have the possibility to process float glass, the flat glass, in different steps. We have the possibility to cut the glass into pieces, then to wash it, to grind it. And then we have the possibility to laminate these laminated safety glass. And next is also planned that we buy thermal processing machine for thermal heat pre-stressing of big pieces. And we have also the capability to 3D print glass. We have an adhesive lab, and we have also the facade test rig to bring new facade products of students' projects into facade to the real environment to see if it fits with the environment or not.
Well, that's really impressive. I mean, you have kind of the full processing chain over here, right? But do you also work on switchable glass?
Yes, we have here in the facade switchable glass. Here you see it's black if you go inside. It's not really black, and if you push the button, it switches in 2 seconds in transparent way. This is a switchable glass here.
All right. I mean, at glasstec we see these products for quite some years already, right? But is there really is that now coming into the market?
We hope so. It's a big innovation, such a product, and we hope also the customers buy such products to bring it into facade. And if you want the energy in you have to clear it so that it's transparent. And I think this is a great chance also for the customers.
And if it's only now taking 2 seconds to darken the glass, then I think this is really the step forward, right, that we were waiting for.
Yeah.
Thank you very much, Matthias.
Thanks.
So, thank you, gentlemen. It was really, really lovely being here in Darmstadt. And I think you have a wonderful facility here and at the Glass Competence Center. And I look forward to seeing all your innovations at Glass Technology Live in Düsseldorf in September. Thank you so much. See you in Düsseldorf. Thank you.
Thanks. Bye.
Bye-bye.
See you.
Bye-bye.